Hey guys, so first of all, thank you guys so much for checking out this video. If you've ever thought about building batteries, and specifically 18650 or 21700 lithium ion batteries, one of the things that you've probably come across is spot welders. In order to build battery packs, one of the best ways to be able to build them is by using a spot welder and spot welding together with pieces of nickel or pieces of copper. In this video, we're going to talk about spot welders, and we're going to compare 6 different spot welders that we have. And we're going to talk about the different types of spot welders, which ones are good, which ones are bad, which one's for you, and hopefully you're going to learn everything that you need to know about getting a spot welder for your own battery building needs. The spot welders come in a variety of shapes, sizes, prices, ability to weld, and we're going to talk about all the different types right here. So the first type of spot welder that we started using is something that looks like this. It's a transformer-based spot welder, and my limited understanding of these is that you have a transformer here that's literally pulled out of a microwave, and you plug it into a wall, you get 120 volts out of the wall. This is going to turn that into a DC voltage, and then it's going to run through this transformer, and the transformer is going to drop the voltage way, way, way down, and it's going to ramp the current way, way, way up. So something like this, very good spot welder, but pretty difficult to put together. You really have to do a lot of work to pull the transformer out of a microwave, but we'll dive into a little bit more detail on how well this one performed. The next type of spot welder is the one that has a lithium battery that is built into the unit itself. And so what it's going to do is it's going to have a lithium battery that's able to output a very, very high amount of current. So it's a high discharge cell. And then there's going to be some MOSFET drivers, and it's going to input a high current pulse into whatever you're spot welding. Usually it's 1 or 2 pulses. The 2 pulses being the first pulse is smaller and then the second pulse is bigger. These are really nice because they're convenient, they're small size, generally they're affordable, but I don't know how well they work. And in my experience, if you're wanting to weld thicker material like 0.15 pure nickel or 0.2, these may or may not cut it, but we will find out. The next type, which is a very interesting type, and I haven't seen many of these, is the capacitor style of spot welder. So these are cool because there's no battery inside. It is depending on capacitors. And with this particular unit, you plug it into the wall, and originally you have to wait about 30 minutes for it to charge up. And it has a huge bank of capacitors, and it's storing up energy for, a good chunk of time. And then when you weld, it's taking the energy from the capacitors and dumping it into the nickel. What's really good about this is that it doesn't have a small lithium ion battery inside, which is prone to failure or prone to maybe overheating from prolonged use. And these are still a reasonable price point, and this one has quite a lot of power. So we're going to test how much power it has. The final type is going to be the style where it's just a bunch of high power MOSFETs. This is a K-Weld module. So the K-Weld is kind of the OG of spot welders. It's sort of seen as like the holy grail, and for good reason. There's some really, really nice MOSFETs in here, and it's able to take 2000 amps. The downside is that you have to provide a separate power source. So normally something like this would get hooked up to a car battery or another high discharge lithium type cell. So that's another factor. These are a fairly expensive-ish unit compared to the rest, and then you have to factor in the price of the other power source, and then you have to have something to charge the other power source. But these things are super powerful, and we'll dive in to see just how powerful they are. Okay, so the materials that we will be using will be 0.1 millimeter pure nickel, 0.15 millimeter plated steel, 0.15 millimeter pure nickel. Those are going to be our beginner and intermediate tests. And then if the welders pass, we'll move on to the advanced materials, which are 0.2 millimeter pure nickel, 0.3 millimeter pure nickel, and then the classic copper nickel sandwich, which is 0.1 copper, 0.15 plated steel. This is generally the hardest to weld with the 0.3. We'll see what survives. Pure nickel has a much lower resistance than plated steel. So pure nickel is harder to weld, but it's also more expensive and it does not corrode. So nickel is a really important material for us to be able to weld. Otherwise, down the road, if we use plated steel, these are way more prone to rusting. So that's one of the most important considerations with the spot welder, is that we can weld a non-corrosive material or a non-corroding material. Okay, first one up is this AWithZ handheld spot welder. Now what I love about this thing is the form factor. It's super easy to hold and we'll see how powerful it is. So pretty much we power this thing up by pressing and holding this side button, and we're gonna go right to the max power level right away. So we have our gears up here. It shows us number 1, so 2, 3, 4, 5, 6, 7, 8, 9, 10. I think this is the highest, yeah. So we're gonna go right to the max, and we're gonna start off with our easiest material, which is 0.1 pure nickel. Okay, so that seemed to hold pretty good. 0.1 pure nickel. Let's try that again. This time we'll do 2 welds. 1, 2. And that holds. It doesn't break the material when you pull it off, but that is an acceptable weld. So we'll say pass. Next we'll do 0.15, and we are on max. So these were charged overnight, so this thing should be operating at full power. 1, 2, and that's a pretty good hold. So I think we passed. We'll try one more time. Okay, so not a super strong hold, but it seems to get the job done. So we'll say pass. Okay, next material, 0.15 pure nickel. Now this is a big test because this is sort of what we want to be able to do at minimum for welding battery packs together, because at least we could do a couple layers if needed for high discharge packs. So let's see, we're still on max. 1, 2, no dice. That just popped right off. 1, 2, 3. You can see that there is very little discoloration, and it just kind of pops off. So we're gonna say no go. Okay, so this was able to do 0.15 plated steel. So next up is going to be this Kerpu spot welder. It is listed as having 650 peak amps that it's able to discharge, and a 5,000 milliamp hour battery. So we have this little unit that we've made up for it. So we're gonna see what this guy can do. This one is also fully charged overnight, and we will set it to its highest. Okay, so it is on max. Let's try 0.1 to begin. And the reason that we made it have this handheld unit is so that you can hold the nickel with one hand and then spot weld with your other. Okay. 0.1. Ooh, popped off right away. Let's try that again. 1. Oh boy, this one is not showing much promise. No dice. Okay, so that one does not pass. Let's try the 0.15 nickel plated steel and see if it's able to hold that down. Nothing. Okay. So this one fails all tests. So probably don't buy this one. The next one we're going to test is this Sequre SQ-SW2. This one looks a little bit more promising. It was a little bit more expensive, and it seems to be a more quality unit. You can even feel that it has a little bit more weight. Has a nice display. We charged this overnight, so it is full. You set the power with this milliseconds, so it's just controlling how long the pulse is. So again, we are going to try this on max, and we'll see what it can do. Starting off with 0.1 pure nickel. Oh yeah, I could even see it get orange. Wow, okay, that's that went on there pretty good. We'll try that one again just to make sure. One, two. It's on there pretty good. I would say that's a pass. You really rip at it, it comes off, but I will say that's a pass. Okay, let's try 0.15 plated steel. Okay. Oh yeah. That's on there good. I think the plated steel, even though it's 0.15, is a little easier to weld than the 0.1 pure nickel. So that's on there so good that you can't even get it off. So we have to rip it off with these little tweezers. Okay, now 0.15 pure nickel. So this is an important one to be able to do. This is kind of, in my opinion, the minimum threshold that you'd want. Okay, that is 2 welds, and it's on there. It's on there pretty good. Okay, I would say that's a pass. We'll do that one more time. I'll have to switch cells soon. It's 1 weld, 2. We'll do a 3rd weld. Well, it popped off pretty quick. Let's try another cell, just in case that could be. Final test for 0.15. 1, 2. So it is on there, so I will give that a pass. It's enough to get the job done. I can already feel some heat develop in these cables, so that was not a lot of welds. That's one thing you want to keep in mind. If you're repairing a battery and you only have a couple welds to do, this is probably going to do the job. But if you have a big pack to build, then these cables are going to get super hot, and likely whatever is inside is probably also going to get hot. That popped off. Let's do 0.2 just for fun, just to see if it'll stick at all. Well, a little bit. A little bit. Not too much, but for a weld repair, it might work. Wow, sticking better than I would have guessed. Okay, I'd say that does work. I guess for fun, let's try the 0.3. This is basically like a plate, very thick. I have a feeling it's not going to stick, but we'll see. Not quite. That popped off pretty easy. Okay, so we'll say 0.2. It gets the job done, but barely. If you have a pack to repair, I think it would actually make the weld stick at 0.2, but it's not going to be a very secure pack if you were to build it completely with this type of spot welder. So we tried this out and it does not work. Something is, I believe the MOSFET or something is shorted. So something like this, I used it for about a year and it worked pretty well. And it was able to do 0.15 pure nickel somewhat reliably, which is why we got away from it. But right now it's just totally shorted. So when we tried, we already blew a hole right through a cell, which we should have got on camera, but that's okay. So we're gonna push this one off to the side. This one is definitely a big question mark if you want to go down this route. The good thing about this is that the module itself is super inexpensive and you can usually find microwaves at a landfill. So if you're willing to do the work, you can get something like this. Is a pretty solid unit. You can build for probably like 30-ish bucks. But it's going to take a few hours to dig out everything of the transformer and pull out the one side of the transformer. Just some thoughts. The next one we're going to test, I'm looking forward to this test because I haven't really tested it out, but it's this Docreate capacitor style spot welder. So we plugged it in, it's fully charged. The voltage is at 5.3, so it apparently needs to be above 5.0 volts. The capacitor's inside. I believe there's two 2.7 volt capacitors in series. And this has a pretty big power range. It goes up to 120, which is a neat measure. Not sure why it's not 100, but 120. And I tested this before and it's advertised to be able to do 0.2 pure nickel. So we'll go straight to 0.2 and see if it is able to do it. I'm gonna set it at 80 so we don't blow a hole through anything. We may have done that before. So 0.2 pure nickel. Okay, that's a pretty nice looking weld. Boom. Okay. Oh yes, that's definitely on there good. Okay, nice. Well, that's pretty impressive. So I did the 0.2 pure nickel. Let's try 0.3. And that was only on level 80 out of 120. Okay, so 0.3 pure nickel. Do one more. Okay. No, that popped right off. Let's try that one more time and we'll try it at max. We'll try it at 120. Okay, 0.3 millimeter pure nickel, welding at maximum power, 120. Wow. Well, it did stick. It definitely did stick. And it stuck pretty good. We'll try that one more time. Okay. Test 2, 0.3 pure nickel on gear 120. Yeah, I mean, it definitely stuck. It's definitely sticking good. So that's pretty impressive. So it did pop off after quite a bit of effort, but let's try a copper nickel sandwich because I think that passed the test. Okay, copper nickel sandwich is on max power. Our copper nickel sandwich is 0.1 copper and 0.15 nickel plated steel. Nice. Wow, that's on there. Wow. Okay, we really had to rip that off. That went on there really good. That's pretty impressive. All right, let's try one more thing. We'll try copper with 0.1 pure nickel. Just that way we could have a less corroding surface. Let's see if it'll work. I'm already thinking it probably won't, but let's see. And sort of, it's stuck, but I wouldn't say it was a super good stick. But overall, wow, that is some serious power. That stuck 0.3 pure nickel. It did 0.2 no problem. It did copper nickel, or the copper nickel plated, no problem. And then it did copper with 0.1 pure nickel and it made it stick. That's pretty dang good. So this is a pretty solid unit. One thing I want to test afterwards is how long it takes for the capacitors to drain and whether or not this can weld continuously. So we will try that a little bit later. Okay, so this is our K-Weld setup. Now it might look slightly ghetto, but we'll walk you through exactly what's going on. So we've got the K-Weld right here, and it is directly attached to this car battery. This is a 12-volt car battery we got from Princess Auto, and then we have it plugged into a automotive trickle charger, and whenever we have our power bar on, we're charging it at 2 amps. So this battery is a beast, and it's basically never going to wear out on us, at least like not in one session. Over a couple of years it will, but we replace this every couple of years. We also have this soldering fume extractor, and so what's really handy about this is that because this is a multi-use station, we got our soldering iron here. This allows us to extract soldering fumes, but it also allows us to extract heat out of the K-Weld when we're welding, because this thing gets quite hot and the K-Weld unit itself does not have any kind of fan for exhausting out the heat. So this is pretty much our setup. And then one thing that we wanted to mention too is that these hand units, this allows you to weld with one hand and then put the nickel in and lock it down. It's actually quite a safety feature because otherwise we're taking the nickel, placing it on, and then we're grabbing 2 leads and welding them down. So at some point you're not holding the nickel at all. Whereas this way you can just lock it in We even went to a pretty far extent to build out a, at one point we built out a pneumatic actuating K-Weld unit inside here so that we could literally use 2 hands to hold the nickel, and then we'd use a foot pedal and the whole unit would drop down. It worked pretty well, but this is a little bit easier to use. And when this gets hot, we have an exact handheld unit that we can swap out. So with this setup, we can just go continuously. We could do 5 batteries in a row. And we'll just keep swapping out this as it gets hot. This will be getting heat pulled out of it. If the battery starts to run down, then we can turn the trickle charger up to 10 amps so that it's charging the battery faster. And then the only thing we have to monitor is if the battery is getting hot, which very rarely happens. But that is a look at our setup that we use on a daily basis. So the really cool thing about the K-Weld is that it actually delivers based on amounts of energy. So that J stands for joules. So originally you calibrate the machine, and then from there you choose how much energy is going to go into the weld. The big difference between this method and just using another method such as pulse time or amps is that as things heat up, the resistance changes throughout the cables, throughout the battery. So calculating based on energy is the most consistent way to have one weld be the same from the first weld as the 1000th weld. So that's a pretty cool way that they control this machine for energy. So let's test what this thing is able to do. All right, so we know that this thing is able to easily do the beginner test. So we're gonna go straight to 0.2 millimeter pure nickel, and we're welding this at 40 joules. All right, so let's test at 0.2 millimeter pure nickel. We're welding at 40 joules. And that is a very, very, very solid weld. Wow. And this is 40 joules, and the K-Weld is actually able to weld at, I believe, a max of 300, I believe. Well, just keeps going. But this thing is so powerful that you can actually spot weld thin gauged sheet metal together, like stainless steel, 22 gauge or 20 gauge. So this thing is super overbuilt, but if you're building a lot of packs, that's a good thing. That's a good thing. Okay, so now we're gonna do 0.3 pure nickel. We're gonna turn this up to 60 and see how that welds. And it sticks, but probably needs a little bit more energy. I think we'll swap out this cell. Okay, 0.3 millimeter pure nickel. We're welding at 80 joules. Let's see how well this sticks. You can see that there's a little bit of copper that actually burns off, and that's a sign of deep penetration. Yeah, so that's on there good. So that very, very strong weld on 0.3 millimeter. So much so that when you pulled it off, it actually made a little out dent, not an indent on the cell can. Okay, last test, we're gonna do 0.1 copper, and we're gonna try 0.15 pure nickel right off the bat, just to see if it can do it. It is sticking. That's pretty solid. That's on there pretty solid. So we weren't able to do that with any of the other machines. That is on there good. So when you have a really high-end machine that's going to be able to do these copper nickel sandwiches, what's really amazing about copper is about 4 times more conductive than nickel. So if you have, for example, 0.15 millimeter nickel, and you have 0.15 millimeter copper, the copper is going to be 4 times as conductive, or it's going to be equivalent to 0.6 millimeters of nickel, or 4 layers. So usually 1 layer of copper is all you need, even in high discharge packs. And it's also very good at dissipating heat. And yeah, it's a pretty awesome material if you're doing high discharge packs. So being able to do that copper nickel sandwich is very handy. You need a high-end welder to be able to do that. Those are just some thoughts. So final thoughts on this guy, the AWithZ. This is a pretty cool handheld unit. Not very expensive. It has a decent amount of power. So we were able to weld 0.1 millimeter nickel and then 0.15 millimeter nickel plated steel. And that is often enough to do a low powered pack. Or if you're building like a power bank or something like that. Not a very big expense, doesn't take up much space. Pretty cool. So solid for like very, very starting out, or just having something like this on hand to do minor repairs. Yeah, solid. This guy, the Kerpu 650 amp, 5000 milliamp hour. Unfortunately, we didn't have any luck with this thing. Maybe it would be a little bit better if we used a different lead or leads for it, but it just felt like it didn't have any power. It was fully charged. We weren't getting anything reliable with 0.1 pure nickel or 0.15 nickel plated steel. I would probably say stay away from this one. So this one, the Sequre SQ-SW2, I was pleasantly surprised with. This thing seems to have quite a lot of power for being so small, so handheld. It has a really nice interface on it, the color display. It looks like this is a pretty solid unit. So if you're, I would say this would be my recommendation for a starting out type of spot welder, kind of like at the lower end. If you're doing small packs or repair, I would say this guy is probably the one you're going to want to go for. Okay, now looking at the capacitor style, the Docreate. This one really positively surprised me. Works really well. This thing can build some serious packs. You can do 0.2 millimeter pure nickel. The one caveat is that because this is capacitor based, you're plugging it in. It comes with a 12 volt 4 amp charger. So that's only about 50 watts, which is not a lot of charge going in. So when you're using the unit, the capacitors start to deplete and they start to get low. And once the capacitors get below 5 volts, they fully charge at 5.4. Under 5, the welds start becoming less secure, less reliable. So we had a 12 volt 5 amp charger that we plugged in and it still worked. So I'd be curious to find out how much of a charger that you're able to put in, because you're putting a 12 volt DC charger in, and then it has its own CCCV, constant current, constant voltage charger that's charging up the capacitors. So maybe you can put in a 12 volt 10 amp charger and it's going to actually be able to keep up. Overall, really, like you could build serious packs with this guy. You're not going to be able to weld batteries all day, but if you have, you know, a battery that you want to build, this is going to get the job done. You might have to take a couple breaks here and there to let everything charge back up, but really solid, especially for the price. You don't need an external car battery. Really solid. If I was starting out, I would probably go for this one, because building packs and kind of having something reliable that's going to get the job done, really impressed. All right, and finally the K-Weld. So the K-Weld is totally a beast when it comes to spot welding. If you're doing battery packs, it can do, you know, it can put battery packs together all day long, as long as you have a cooling fan and a supply that's not going to overheat. And it can even spot weld panels of steel. So this thing is really overbuilt, really, really solid. If you want to kind of do it right, or if you want to have something that's you're never gonna not have enough, then this is probably what you're gonna want to go for. But you do have to consider that you have to buy something to power it, and then you have to buy something to charge whatever is powering it. So This is probably double the investment at least compared to even our capacitor-based option. I believe this is around like $250 to $300 for the module, but we'll verify that price, and then a battery, and then a charger for the battery. But this is what we use, and we're able to just weld packs up all day. You know, they haven't given up on us yet. These things are really, really stout. Yeah, really awesome. So, excellent machine. So one thing that makes spot welding way easier is when you're able to use a handheld unit and just hold the nickel in place and place it down. We really tested a lot of these different options, and you've got this guy, which you can find on Amazon, 3D printed with copper bars going through, super simple. What we found with this style is that there's a lot of slop, a lot of movement there. This one and this one are from the same company, Sunco, and they both worked pretty well, but we had a lot of reliability issues with this one. And then this one, it seemed like the needles were too hard to replace. This one was a nicer one. It was CNC machined and pretty beefy, but honestly the best one for us ended up being this guy, which is great news for you guys because this is also super cheap. This is like a $20 AliExpress unit. Very easy to swap out the needles. It has a switch built in so that you're able to just plug it directly in, so you can use automatic or manual mode depending on what welder you're using, and then very thick copper bars. So if you are going to be doing a lot of spot welding, building a lot of packs, it definitely is a lot easier to be able to use one hand to control the weld completely. This guy is super good. We'll put a link in the description where you can find something like this. But yeah, it makes life a lot easier. Highly recommend it. Okay, so final overview. We went through all these spot welders. The transformer-based model, unfortunately, wasn't working, so didn't really get much of a test on that. I do think these have a lot of potential. They're just kind of the most setup, the most amount of work that you have to do to get something like this working. This guy, yeah, I can't say I recommend this one. This one good for, you know, if you're the minimum viable product basically, or the like minimum effective dose, it will spot weld. It'll stick things together. You're probably not going to be building anything big. This one, really solid if you're wanting to build small packs and you're wanting to be able to do repair and kind of have the power to repair. If a battery comes in, it has a 0.2 millimeter nickel that's come loose. This will be able to stick it. This guy can build some serious packs. You're just going to have to either give it some brakes to charge up or put a bigger charger on it. And then of course this guy, the K-Weld, if you're willing to spend the money and you're willing to kind of do it once only and then be able to be confident in all of your battery building endeavors, then you can just go straight for the K-Weld. A couple notes. So when you're considering doing battery packs, nickel plated steel, copper, you want to make sure that you're building the pack, but then 3, 4, 5 years down the road, if that pack ever goes to somebody else, that's where the nickel plated steel becomes kind of dangerous because it can rust. And once it rusts, then the material starts to fall away and the resistance goes higher and they become sort of more dangerous. The nickel, pure nickel, will never rust. So you really want to make sure if you're building a pack to build it with pure nickel. If you're doing something that's just a small, tiny project, nickel plated steel is fine, but really strongly recommend pure nickel and something that's able to be up to the task. So hope you guys enjoyed this review. Drop a comment, like, subscribe. We are giving away for our 2K subscriber giveaway on this video. So drop a comment on this video. We're going to pick our favorite comment and we're going to send you some cells and we're going to send you one of these spot welders so you can build your own pack from home. So pretty cool opportunity. That's for Canada, USA. If you win and you're from somewhere else, we'll find a way to get you something pretty cool. Drop a comment and hope you enjoyed this one. So guys, keep it on 2 wheels and we'll see you in the next one.